However, in the long run, the group agreed that those who currently have low discharges shouldn't have to decrease as much as those who had high discharges at the start of the scheme. And to achieve this, we proposed an allocation regime that based free allocation on the potential nutrient loss from a piece of land. So how would this look in practice? Land with high current leaching, such as dairy or sheep and beef, would receive high free allocations at the start of the scheme, but over time these would decrease. Compare that to some underdeveloped scrub land, which potentially could have been great dairy land but was underdeveloped when the scheme was introduced. Over time, this will see its free allocations increase, if not in absolute terms, then certainly in relative terms. It's important to note that reaching the environmental goals of the Rotorua catchment will require pretty significant decreases in nutrient discharges. In other words, the environmental cap will be a lot lower than current nutrient exports. Which brings us to our second allocation question, and that's how do we share the cost of meeting these environmental goals and mitigating nitrogen between farmers and the wider community? Well, there's a couple of options. If the community decided that sources should bear all costs of mitigation, they could allocate just at this bottom line here, this dotted one. And this would implicitly mean that all of the farmers would bear the total cost of reducing nitrogen discharges down to this level. Alternatively, the community might decide that farmers should bear no cost of meeting these environmental goals, and they could allocate equal to current exports. They could then get back down to the environmental goal by buying back some of those allocations from participants. And buybacks could be handled by some central buyer, such as the Lake Taupo Protection Trust's role in Taupo. And buybacks also have the additional benefit of increasing information on pricing and the catchment, and also increasing liquidity. We fell somewhere between these two extremes and decided to allocate between them, where implicitly this blue line is the cost of mitigation borne by farmers, and this red line is buybacks, which are funded by the community. One final note, we propose that this division of costs is clearly outlined in advance, and this rule or formula of cost sharing is set in stone so that in the future, when changes to the cap might need to be made, a similar or exactly the same division of costs could be applied once more. Now that we've dealt with allocation and cap setting, we can move on to trading, which is the central part of the policy. And when designing the trading mechanism for Lake Rotorua, we had two key principles in mind. The first principle was to minimize farmers' costs of participating and trading in the market. And there was an obvious motivation for this. In many existing nutrient schemes, not exactly the same as this one, but nutrient schemes nonetheless worldwide, there are very low levels of trading and very low levels of participation from participants. And one of the key reasons for this is high transaction costs. And particularly, participants often find it uncertain and expensive to get their trades approved. Obviously, we wanted to avoid this in our trading scheme because we want to maximize trading to ensure that those sort of cost-saving trades can be made. The second principle that we kept in mind when designing the trading scheme was that participants should only be held responsible for what they can control. Anything that's out of farmers' hands, such as weather bombs, changes in science, these things they will not be held responsible for. So how does this work in practice? All estimation of nitrogen discharges is done using Overseer, as Susie mentioned. Overseer uses easily collected and auditable inputs, things like the number and type of animals on your farms, your soil type, slope, farm management techniques, and it uses these to model nutrient discharges from your property. It has the additional benefit of being freely available to New Zealand farmers and has already been used for policy in Taupo. We propose that this version of Overseer is updated regularly to ensure that the latest mitigation science and technologies can be implemented, but that at the start of each compliance year, that year's Overseer is set in stone to ensure that farmers have some certainty over what they will be responsible for. During the year, farmers can pretty much run their farms as they see fit. The change from status quo comes in as they will have to have some understanding of the nutrient discharges that are coming off of their property and have some knowledge of the number of nutrient allowances that they hold. They have to ensure that come the end of compliance year, they have enough allowances to cover their nutrient discharges. All of this can be estimated using Overseer, and once farmers know how many allowances they have and how many they need, they can then go out and trade with whoever they want to, be that a central buyer or just over the fence. The key principle to keep in mind, as I mentioned, was to avoid large trade approval costs. So to complete a trade, farmers can shake hands, sign a contract, and there's no trade approval required. Regulators won't be coming in and assessing each trade as they happen. Instead, farmers will just have to register a trade has taken place at some central registry. Come the end of compliance year, farmers will have to hand over some overseer runs to document the nitrogen discharges that were leaving their property in the year, and some backing data to show compliance. The regulator will then assess this, make sure everything looks in order, and if it does, delete the appropriate amount of allowances from the registry. However, if the return looks somewhat suspicious, then they will hand on all this information to an audit agency. This brings us to enforcement issues. Now, ideally, this will be relatively self-enforcing, but nonetheless, LEB are swift, predictable, and large, such as those available to regulators enforcing the ETS. This lets it, unfortunately, under the RMA, these sorts of penalties might be quite difficult to instill. And Vernon Rive is going to discuss this and a couple of other legal issues after morning tea. The final issue I would like to touch on today is governance. Nutrient trading is a new and innovative solution to a long-term problem. And as a result, the one certainty is that unanticipated issues are likely to arise. To maximize certainty, we really need to plan for these changes in advance, which will help ease transitions later on. The key things to plan for will be, like I said earlier, determining cost-sharing rules or formulas up front. This will ensure that future discussions, for example, if the community decides to change the nutrient cap, focuses discussion on what the socially optimal cap will be, rather than who will be paying for any changes. We also propose that decision-making is closely supported by science, and which will be particularly important, for example, for updating Overseer. And finally, to improve certainty for the farmers, we propose that any changes to the scheme be announced with years of advance warning. So to conclude, we believe that a nutrient trading scheme such as that proposed here, one with low transaction costs, one that maximizes participant flexibility, will allow environmental cost effectively and with certainty. Now I'll conclude there, but I'm happy to take questions.